All right. Hello, everyone. So hope you had a good lunch, and hopefully I'll not make you sleepy after lunch. Okay, so the talk that we have today is MLOps under attack. So it's basically covering threat modeling, MLOps systems, modern AI systems, and set some expectations. There's no magic going to happen. We're not going to attack anything right now, and you'll see some magic happen. It's a talk about looking at MLOps, development of AI systems in a much more detail. And that's how we'll get there in a bit. A quick bit about me. Currently I work with HackerOne, run some security strategy ops for some of our customers. Previous, I was with a boutique firm called Not So Secure, running consulting. Things I love, you can talk to me about AppSec, cloud security, proactive security, vulnerability management. All right, so what are we going to talk about today? Overview of ML lifecycle. When I say ML lifecycle, MLOps, this is beyond the realms of just LLM. We'll come to LLMs a bit, but in general, and why we are talking about it now, how come suddenly it's so important, we all probably know. Platforms that are in use, what's the supply chain looks like, what are the attack surface, what are the attack scenarios, and how can we build for security? How do you build more secure systems? And we leave the session with some example tabletop scenarios. So there are four different takeaways that you can take. If you are a bug hunter, you can look for areas where you could go back and research and find bugs. If you are a security engineer, you could look for things that you need to build security around. What are the places? How would you look at attack scenarios? How would you look at security boundaries? How would you look at architectures? And if you're just a general curious person, all of this would probably give you some food for thought to go back and start researching. The realm is pretty big. The only problem is it's in a very nascent stage and there is not much being looked at right now. So let's get started. Understanding MLOps, it's a unified engineering practice and cultural approach that integrates ML system and ML systems ops. To best understand it, it's a replica of DevOps in an ML environment. So basically in a DevOps, you have a system to integrate development and operations of software. And in this, you have machine learning systems. So it's instead of software, here we are talking about data a lot. So you'll see that. So it's an overlap or the kind of place where people process technology. People are the personas that work on ML systems, like data scientists, ML developers, DevOps engineers. Process is the whole CI/CD, deployment, design, planning, all these kind of things. Technology are the platforms that we use, which we'll talk about in a bit. So what's the process looks like? So this is the holistic. Now the text might be smaller because of the projection. I'll read it out just so that it's clear for everyone. So in a software development, you have plan, design, development, testing, deployment. So similarly in MLOps as well, you have a similar life cycle that this goes through. So planning and designing is basically where a set of data scientists, a group of data scientists will come, define what's the problem that they want to build a model for. They'll frame the problem, they'll collect the raw data, they'll clean it, process it, and build features. So there's a concept called feature engineering. Then they'll go into training the model. So they'll write the actual code for training the model. Or if it's the modern LLM systems, they'll take the foundation model and they'll fine tune it. So they'll write code to fine tune the model. Then you have evaluation, test cases. Evaluation is something which is pretty buzz these days. So you may have heard about performance evaluation, testing, if the model is actually performing the way it's supposed to perform. Then you eventually deploy that kind of model into production. The deployment can happen in multiple ways, client-side apps, APIs. And during the deployment, it's also the backend infrastructure. How are you doing it? Are you containerizing it, etc., etc.? And then eventually you have to manage and monitor the model. So, and then it starts an iterative loop, because the moment you launch a model in a production, that model is sort of outdated because there is new data now. So you monitor the performance of the model very closely in an MLOps environment to see how the performance is. You look for benchmarks and all that kind of things. And then you trigger like a retraining process based on certain conditions. So if you look at this whole life cycle, in the modern terms, you may have heard these terms being thrown around: pre-training, training, inference, these kind of things. So if you look at this whole life cycle, the half of plan design is basically pre-training. So that's where data scientists are working on framing the problem. They're like collecting data, they're cleaning the data, like if the data needs to be organized in a certain way. So this is all pre-training. Then everything falls under training until the evaluation is complete and the team is ready to deploy the model. And then deploying and monitoring the model comes under inference, wherein you're also exposing the model in some form to your end user, and the end user is querying your model. So what you see in terms of the modern LLMs these days, ChatGPT, etc., it's basically inference. Like what you're doing with the model is you're inferring the model. Okay, so let's start with some tooling. So in the plan design phase, what tools people work with? Jupyter notebooks, I guess most of you may have heard. Web IDE with computational kind of technologies available in the backend, so you can run a lot of computation using Jupyter. So it's a favorite tool among all data scientists. They use it to clean data. They use it to kind of work with data. Hugging Face, we'll talk about Hugging Face a lot later in this, but like Hugging Face it's sort of GitHub for AI models, and this is where you can download a lot of pre-built models, like pre-made data, etc. Git, of course. Pandas is another ML library that people use. During the training stage, folks would use, again, frameworks like PyTorch, TensorFlow, MLflow, Kubeflow, weights and biases. So these are all sort of platforms that are kind of useful in different. So you can build a training pipeline in MLflow. You can build an evaluation in MLflow. You can also build a deployment through MLflow. So these are common tools. So think of MLflow as, how many of you are aware of Jenkins in the DevOps world? Right. So it's exactly Jenkins of the MLOps world. Then there are evaluation tools as well, things like Alibi. Again, MLflow, weights and biases are tools that can give you that, the evaluation libraries and the tooling that you need. For deployment, it's pretty standard. Like the way you deploy ML models is again using similar infrastructure. So you'd want to containerize the model build and expose it in through APIs and stuff. So traditional infrastructure, be it cloud or non-cloud, that comes handy here. So both Docker, Kubernetes, these kind of, and then there are these platforms themselves offer deployment kind of approaches. So you can package your model into the platform and they'll handle the deployment for you. So they'll basically offer you like a inference as a service. And we'll talk about that a bit as well. Selden Code is another platform which gives you deployment. And then for finally monitoring, you have again the regular tooling and technologies like Splunk, Elastic, Prometheus, Grafana, etc. This is where you want to closely monitor each and every metric that you've decided for your model to understand its performance. Not just performance, but also you'd want to do lots of like security related monitoring, regular reliability monitoring, things like that. Okay, so now all of this could be done using managed cloud pipelines as well. And that's where the hyperscalers come into picture. You see like Amazon has a tool called SageMaker. SageMaker provides this entire life cycle using SageMaker Studio, SageMaker Pipeline, SageMaker Clarify. There are like lots of like modules within SageMaker. Then you have Azure AI. Azure AI does the same thing in the world of Azure. And then you have Vertex AI, which does the same thing in the world of Google Cloud. So if you have to build a kind of an MLOps for training models, if you leave every tool at the top layer and just look at the cloud managed frameworks, I think that will work. But it gets more complicated when you get into the cloud world, but it's very managed. Like you don't have to run those tools. I think the vulnerability ecosystem slightly is better, of course, in the cloud world. So yeah. So this forms the whole picture for your like MLOps. You have the whole life cycle: plan, build, evaluate, deploy, manage. Then broken into pre-training, training, inference, the tooling that's used at every layer. And think of this, like all of this tooling is your attack surface, basically. Like, so that's how it looks like. Now, just in the way you look at like DevOps, it's similarly in MLOps, which is like you could run this whole life cycle manually. You could run this whole life cycle semi-automatically, and you could also automate this whole life cycle. And that's where you would have the whole ML pipeline build coming in. You could do the iterative process, which is how do you kind of trigger retraining? So based on certain conditions, changes in the flow, like, so in a DevOps world, as soon as there is a new code base being pushed, you will want to push a build. But in MLOps world, you would want to probably do it for data. So as soon as you have some data being kind of pushed and there is some trigger condition that you can define, you can push, like a new training or a retraining, basically. So let's look at this whole ML model development lifecycle in a slightly different way. So if you want to understand it in a much more practical, like public-oriented way, so you'll have a model source. Model source will be basically the data. You'll train the model based on that data, and the data sets, the frameworks, the models, all the third-party libraries, everything will come into the training. Then you'll deploy it to a model hub. Again, ML flow, one example. You'll download Model Hub would be sort of like a Google Drive or a shared or a drive where you have different versions of model that you've trained, and you can download any of them to put it in production. So you don't have to put all models in production. This is how it looks like. Train model. This probably won't be visible, but this is like a sample pipeline script. It's basically a bunch of Python code to import bunch of libraries to prepare data. It's a churn prediction model based on certain customer data, how much churn could happen. So you would build some categories of that customer data, like what categories of customer do fit in. Then you'll split the data into a bunch of test kind of data. Then you kind of train it using the random forest classifier model, and then you start making predictions. So this is as simple as that in a super high level abstract way. But it can start getting complex the more you involve. So just to give you an understanding, like this is how it look like. Then once you've trained it, you would want to deploy it to a model hub. This is also called model registry. So this is how it looks like. You have different versions of the model, the dev version, the prod version, the staging version, 1.1, 1.7, etc., etc. And then you'd want to serve the model. So how would you serve it? So what I was just saying. So you've gone through the training process. You have an object, which could be like a pickle file, dill file, something like that. You may have heard. Then you would test it. You provide it a certain input and it generates an output, as it's supposed to. So it's working. So then you can package it in two different ways. Either you embed it, so that's called an embedding. So you embed it into an app. So when you run an inference on ChatGPT, basically the whole GPT-4 or 3.5 is embedded in that app. And then it's also served as an API. So if you're an application developer, you can use the particular the GPT API to build applications on top of it. So these are there are platforms which does for you, like Selden Core, Kserve. These are platforms which will take your model file and it'll basically deploy it for you, and give you an API endpoint that you can start serving or like giving to your customers. And that's where like a lot of challenges come. Like some of these platforms, the way they're deploying, if you start looking at their architecture, like that might be problematic, or that could be an area of research to start looking at. So what about LLM ops? Like, you're talking about ML ops, but how does LLM fits into this? LLM ops is much about, focus is on LLM development and managing the model in production. So it focuses more on the design of entire end-to-end application. So it's not much about training the model from scratch, because that training the model from scratch has happened at companies like OpenAI and places. But fine-tuning happens. So people do fine-tuning. We all mostly do fine-tuning. And then, there is a layer in your MLOps that you can build for fine tuning. And then you monitor it and evaluate the output. This is an example application stack for LLM ops. Very simple yet complicated, which is a user will query. Nowadays, most LLM apps would have some context construction, which is RAG, what we call it, like you. So it'll basically fetch some data from a database, build the context, go to a model gateway, and that's where you will have just next to model gateway, both during input and output, you will need to have input guardrails. For like if you're giving a PII to the model, it'll redact it. If it's generating a PII, it'll have to redact it. So that's important. Now, like 2 years ago, if you'd ask someone, these things would probably not be a part of basic or like a main AI, like an LLM app stack. But now it's pretty much like table stakes. Like if you're not doing some input guardrails, output guardrails, your model will basically become unusable because the amount of data and things it gets trained on. And then you can think of it, you can keep adding layers on top of it. The whole, like the buzz around agents and stuff. So you can have write actions created on top of as soon as an output is generated, you can start creating write actions. You can give it access to a bunch of databases. It will start updating things depending on how complicated you want to get and how much you trust that whole system. And then you would have, of course, a layer of logging, monitoring, and analytics. Okay, so we've now looked at the whole MLOps pipeline, the way the whole plan, design, develop, deploy, evaluate, all the stages work. We've looked at how the whole LLM thing fits into that whole MLOps thing. A quick differentiation when we talk about like ML training pipeline, etc. So LLMs already are trained models, and we are kind of mostly inferring or like building apps on top of it. But the ML ops, because of the buzz around LLMs, now a lot of organizations have started building their own ML pipeline to train other models and do a lot of other things. So the usage has kind of exploded on the more broader scene as well. Attack scenarios. Now, if you look at a bunch of like attack scenarios that are possible in this whole life cycle, these are super basic. Like this is mostly what you hear in the OWASP top 10. But when we think of like, hey, but like the app that I'm querying, how can I do like model poisoning or like data poisoning? There are some scenarios possible, but not much. So all of those like things mostly come into picture when you're looking at the whole ML build process, how the whole things are building. So because the plan design phase is where you're working with data and like initial model for feature engineering, etc. And you're dealing with raw data there. That's why these three attack scenarios are possible. Now you're dealing with personas, ML personas. Remember I told you like data scientists, etc. So who will be your basically target? Like your victim would be these targets, compromising their credentials, and then keep going layer by layer. What does the access control looks like and things like that. Then during the build process, you have beyond the data model, etc., you have code execution, which is very much possible. And that's a big problem that the whole ML world deals with, because the design of the whole models and the data around it is such. Then, of course, during your build process, a lot of people would import a lot of third-party supply chain components, like either, like I said, you're either downloading a bunch of data sets from Hugging Face, you're downloading like some library from Hugging Face for model training, etc. And then during the deploy stage, you have things like, again, model poisoning, extraction. And if the model is getting deployed to containers, there are container escapes and things like that. So let's start looking at attack scenarios in a bit more like one by one. Okay. Credentials compromise. So this is a classic, like you again don't think of it from an AI lens, but think of it from a traditional infrastructure lens. You have your ML developers, you have your data scientists. How do you compromise credentials? You do phishing. You look for, like if you're doing pen testing, red teaming style things, you look for network file shares. You look for like different device compromises and things like that. So there are many avenues through which you can look for credential compromise, and that becomes your initial attack vector. And once you've done that, then you basically have a sort of data scientist, ML developer access. Now, what can you do beyond that? So basically that becomes your attack scenario, which is like you steal authentication credentials through phished or exposed secrets, gain access to inject poison. So again, if there is a data scientist working in the ML pipeline, they're for sure working with data, right? So they would have some level of access. Now that's where the beauty of like doing it securely comes. Like what is the verification process? How much like, alteration is being detected and things like that. Misconfigure. So now let's say you have access. What if there is not much kind of, access control, or like in the world of, let's say, AWS, the IAM policies are not super well done and they're like pretty loose. You start to be like, you'll see that apparently this ML developer access credential that you've compromised has a lot more than that you have thought of, and you can do bunch of things more there. So you exploit overly permissive roles, improperly segmented environments. So for example, your training environment and your deploying environment is not separate. If you've compromised a persona which works in the deployment environment, now you're able to go into your training environment, do random things there, things like that. Supply chain attacks through third-party libraries data. Again, like I said, pretty like code in dependencies, poisoned public data sets. I'll show you some like public case studies like where it's happened, and it's happening like almost every other month or like few weeks. That enables backdoors, data leakage, things like that. And the vulnerabilities in actual ML platforms, like the ops platforms. So these platforms were not scrutinized the way the regular like DevOps platforms are scrutinized. So, and they've it's a very cliche, but like all these ML engineers, ML scientists, they're not security people. So they've never thought of that from that lens. And when you start to do research and when you start to like analyze some of the publicly kind of documented vulnerabilities, you see there is like the maturity level on the MLOps platforms from a vulnerability or like a security perspective is super lowish right now. I think it'll take few years, and that's why like doing a lot of research on these platforms right now is a good time to look for. So things like insecure container configurations, deserialization. So for example, one of the examples I gave you, Selden Core. So there is a publicly documented CVE around that, which talks about like when it deploys model, it doesn't isolate the container. So if it takes your model and it deploys, it puts in a shared container environment. So if you have a container escape, you have basically other Selden Core customers model that you can probably play around with. Deserialization issues, insufficient isolations, etc. So case study. So this is a very good talk from just last year. So the JFrog research team specifically focused on the open source ML platforms. They looked at MLflow, Selden Core, Kserve, these kind of, and throughout the year, they've, I think, disclosed roughly like 10 to 20 CVs across these platforms. It's an interesting talk if you only want to focus on the platforms and go about like finding like issues in them. Then just like a month ago, this group from X-Force did some research, and they published a pretty extensive white paper around the implementation. So they start with the credential compromise situation, and they look at like how things can happen like laterally, internally. So once an attacker has obtained valid credential material, what can they do? They in fact open sourced a tool called MLOkit, which actually does a lot of this in an automated fashion for you. This was a pretty famous, I think most of you or a lot of you may have seen this research last year from Wiz. It was about, so this is where Hugging Face started to become very like in the center of research. So they were able to to abuse bunch of issues in the way Hugging Face was taking people's data, deploying so this was like an inference API attack that they did, which is basically they were able to push a malicious model in their inference as a service kind of offering. And then again, because the tenancy was not shared, so they could use that malicious model to escape out of their whole model and access other private models as well within the whole inference as a service that they were offering. There are other things which is so maybe it's a good time to just pause and talk about. So most of the ML models that the final model that you have, they're in formats like I said, it's Pickle, DIL. I think Pickle is probably the most familiar to most people in security because of the whole serialization, deserialization issues that happens there. But essentially what it does is that it basically executes a Python code without any kind of, if there is a code inside it, it'll execute it if you run it. Similarly, but the interesting bit is that it's not just Pickle. There are a bunch of other file formats in models that do the same. So DIL is another. I think there are a bunch of others that does the same. So if let's say, so the attacks that are super on the rise these days is there are lots of folks who are hosting bunch of AI models on Hugging Face for you to download and use. And they're all malicious in a way that the moment you download and start using, it starts to trigger a bunch of code execution and all that kind of thing. Just I think a week ago, after this Wiz work, Hugging Face implemented a bunch of controls. So even if there is a data set hosted on Hugging Face, data set is supposed to be CSV, XLS, these kind of things. You can put a Python file there, and if you download that data set, it'll execute along with that data set. So they built some controls around it to not auto execute and things like that. But it's still, they also have a Pickle scan module now in Hugging Face, wherein if you upload a Pickle file, it'll automatically scan that for execution thing, if the code is going to execute and all, and it'll give you an alert. But it's still not perfect. Just a week ago, this researchers from Reversing Lab, they picked up a bunch of models that were acting maliciously. And the reason they were not being detected is because they were using PyTorch file format. PyTorch is Pickle, but it's wrapped under a zip file. Then similarly, same JFrog research team detected a couple of malicious AI models, and they were doing the same. They were again exploiting Pickle. So the amount of exploitation that has happened on Pickle file formats in the ML world, and especially on Hugging Face, is enormous. I think they'll come up with more robust controls around it sooner or later. So now we looked at attack scenarios. So thinking of it from if you're a bug hunter, tester, pen testing, bunch of things. If you're only looking at platforms, there would be different sort of attack scenarios. But let's say you're going after an organization, testing an organization that is deploying some sort of ML pipeline inside their organization. So of course you start with authentication and access control related issues. Is there credential stealing that's possible, misconfigured through internal network resources, like I mentioned. Again, misconfigured IAM roles, super, there's this whole SageMaker, the AWS SageMaker that I talked about. So when you start and deploy it from the quick setup script, which a lot of people do, it gives you a permission. It creates a policy which is super liberal in terms of it's super open. It gives you default access to a bunch of things, even creating cognito based pools and stuff like that. Infrastructure issues, again, container escapes and model training, model serving environments. This seems like an area of very interesting research because a couple of platforms have already disclosed issues where people have found that the way they deploy models from an inference perspective is not at all how you would expect it to be. Either some are first of all, you'd be lucky if they're containerizing. Some are even not containerizing. Some don't even, for example, I think Selden Core had this problem wherein they don't even have authentication built in. And when a CV was issued, they actually disputed that CV. I think it was like last year or something, and they disputed that CV. The interesting bit is that there is a company called Oligo. They did research on that, and they found that this whole lack of authentication was actually being exploited in the wild. And they disputed because they said it's an internal use thing. So you can deploy your own reverse proxy and do your own like authentication. Network pivoting through compromised ML instances due to insufficient network segregation. Things like that. So infrastructure vulnerabilities, I think, pretty much remain the same, what you would see in AWS environments or Azure environments or places like that. CI/CD, supply chain, again, third party. So what are the things that people use from a third party perspective in MLOps or like ML development? These are mostly like specific ML libraries. Not much around, but I mean, the nature of software development or any development these days is that there is a lot of pre-built code that people are using. It's not as bad as like an NPM ecosystem, but there is still like a lot being utilized from third parties. And then finally, you have the API and model inference issues, which we hear a lot about, which is the prompt injections of the world. But like SSRF in model serving endpoints becomes very interesting. So if that's one research area to be looked at as well, like, because if you have a SRF through a model serving endpoint API, there is a lot of interesting things that can happen inside the whole ML environment if the other things are not taken care of, which is likely to be the case looking at other things today. So what does the CV landscape looks like? So there are lots of CVs. So something to note. So I was starting to analyze all the CVs for some of these well-known platforms that got issued in 2023 and 2024. So there is absolutely a huge rise. So in 2023, some of these platforms had like 2-3 CVs reported. And I'm talking about some like meaningful CVs, not just like random, like 3.1 or that kind of CVs. And in 2024, like MLflow itself had like, I think 9 critical issues reported. Kubeflow has some of them, again, depending, like based on how their deployment thing works, they have like different kind of issues. Like Kubeflow apparently seems like there is a trend of SSRF issues that is kind of coming up there. This was the most interesting one, wherein proper like internal network reconnaissance was possible. There are things like RC, remote code execution, OS, like command injection. MLflow specifically has a lot of path traversal issues that are showing up in that. Okay, so what do we look for when building like an MLOps environment more securely? Of course, a basic thing would be like you'd want to encrypt training data and model, but like the more important thing beyond encryption is like, I think there is a super like need to do provenance tracking around the data that you're using for training. And ensuring integrity. So things like if you're using AWS S3 object lock. So first of all, modification should not be possible. And then you have things like versioning where like you can retrieve like previous versions. You can see how many versions have been created. So a lot of provenance tracking seems to be a very useful approach in data related layers. Then of course, you do not want to open like access control on training data stores just like that. This is more of a training issue, but like now it doesn't pops up, but it used to be a big concern like a year ago when talking to people, is that like, how do I ensure like I'm not putting sensitive data in training models? So there are well-established services that you could use, or you can build your own custom solutions as well to scan for like PI, PHI, these kind of things before putting the data for training and fine-tuning. So when I was talking about like, like tampering and granular access control, an example service control policy inside AWS. So this is beyond the regular like policy you'll create. Is this service control policy will basically prohibit any changes to Amazon SageMaker models. So you see the delete model, create endpoint, update endpoint, all these actions are completely denied at the organization level. So even if someone, let's say, And of course, it will be allowed based on certain kind of characteristics in the further layer down. So code and model, usual things, you need signed commits, code reviews for all model development, scanning your container images. But again, you scan for like vulnerabilities and like known things, but the architecture is important. How a particular like container is being deployed and how kind of, the whole thing is working. Then you scan for dependencies, test model for adversarial examples, which is basically all the prompt injections and things like that we talk about. Infrastructure, in an MLOps environment, segmentation control becomes super important if you want to prevent like data extraction type attacks. Because again, that's where like an attacker might land in a different stage of the whole ML pipeline. And if they're able to go and access a model which is in production or a data that sits in a plan phase, like that should not be possible. So similarly, you see another service control policy example. So this service control policy basically denies any delete pipeline. So no one could come in your environment and delete the ML pipeline that you're running by simply defining that hole as a SCP. So let's look at like an architecture now. So let's say we start building an ML environment inside a cloud environment mostly. So the first thing that you need to do is like you have a dev environment, you have some data sources. Now your ML engineers or like data scientists will start working using notebooks. So remember that plan design phase we talked about, like notebooks, Jupyter. So they'll start working on notebooks. They'll have a notebook server, which will be a specific, like a subset environment. The work that they've done, the clean data, the clean code, the prepared code would sit inside a code repo. The environment will go in a container registry, like an ECR or something. And then you'd have object storage, which is something like S3 or something. Now, using the container registry and the code repo, you'll build a pipeline service. Pipeline service is where you'll have the build, train, and evaluate steps of the whole life cycle going. Now, once the pipeline has run, the model is trained, you will put it in a model registry. So the example that you saw of model registry. Okay, now this might be not visible again but I'll talk through it. So we talked until model registry. Now, when you run the pipeline service, you would want to have a baseline model and put it in a separate storage to run monitoring on top of that model. The monitoring would be around like performance evaluation, etc. And then you would create, remember I talked about like automated deploys and builds, training. So you'd create triggers on that like storage. The baseline model that you stored somewhere else, you'll create triggers there for retraining. So triggers could be based on if data changes, something like model performance drifts by 5%, 1%, you'll initiate a retraining, something like that. And then from the model registry, the model that is approved, there is more detailed steps in the model approval process that you can go with. But at a high level, the model that is approved can go into two staging and production environments. In staging or production, of course, you will run the basic app architecture, which is you'll have an API gateway, you'll have some probably lambdas or functions that's kind of, calling that model endpoint. And then you're basically capturing all the monitoring management data in a storage. Now that storage you see is again feeding back to the another instance of storage where basically monitoring is happening to inform the whole pipeline service. Now look at this and you see what are the security boundaries you can think of. There are like so many things happening. So you have the data scientists, ML developer. So when they are interacting with the development environment, so that's a security boundary you can think of. Now, between the data sources and the development studio or the whole pipeline, that's where another security boundary comes. Like how is your data sources and the ML studio is kind of interacting. Then when you have done the ML pipeline service, the storage where the baseline model is stored and there is monitoring happening, then there are like external data from the actual public model is also getting there. So how do you kind of, like that needs some segregation as well. Then finally, between the model registry, the whole approval process, after the approved model, you need segregation at the both staging production layer. You need segregation at the final user tester layer as well. So these are different security boundaries you can think of, like, and what are the controls that you'll do? Like, what is the segmentation there? Like, how much, like, what are the, if it's a cloud environment, what kind of firewall rules exist? What kind of access policies exist and things like that. So when building like a secure, based on all the attack patterns or anything like the threat scenarios that you've seen, like when you're building for security, this is like a rough mental model to have. So I think are we good? Okay, we are good on time. So I think we are done. So 1 minute. So the thing to walk away from this is, so when, let's say, either you're about to get into bug hunting for MLOps platforms, or if you're building inside your company, if you're securing, some of the tabletop scenarios are good mental things to think of. What happens if an authentication bypass issue in your model serving infrastructure allows unauthenticated access to model? Think of this, build around this. Attacker has gained access to a notebook server and is attempting to use it for pivoting into more sensitive infrastructure components. Is this possible? How can you prohibit this? Internal user deployed an unauthorized shadow model that mimics your production. Attacker achieved container escape. Model inference API is experiencing a sophisticated DDoS. That's it. So if you're interested in looking for bug hunting, most MLOps platforms out there have a disclosure sort of policy you can look at, and the more like managed programs, of course, like the MSRCs and the Google VRP, have the SageMaker have them through their main programs. That's it. Thank you. I guess we are done on time, so I'll be here in case you have any questions on the side. But thank you.